I want to show you how you can use the power of the blockchain to build the next generation of applications, all right? You don't have to know anything about blockchain. You don't have to be a programmer necessarily to watch this video. But if you want to learn how blockchain works and you want to, learn how to program for the blockchain, then this video is for you, all right? So before we get into that, be sure to subscribe to this channel if you haven't already and click the like button down below. And if you're really serious about learning blockchain, you need to join my free training on my website over at dappuniversity.com/bootcamp. So some of the main ways we're already using blockchain technology are for financial transactions, right? Payments, investing, anything related to do with sending money around. We're already doing it on the blockchain. And I see those use cases growing more and more over time, right? And that's what I'm going to focus on today. I'm going to show you kind of a sample app that we'll actually get into. We'll code it together. That's going to show you the power of the blockchain and what you can do with it with these financial transactions, okay? So also think about it. All right, we've got cryptocurrency already. People are already buying Bitcoin. People are already buying Ethereum. They're sending it around. They're making transactions. They're paying for things with it. And the demand is growing for these types of things. It's being more commonly used. And as that goes on over time, we're going to be able to create apps that actually use this money, this digital money, and create programs that, do stuff with it. All right, that's what I'm going to show you. And this area is prime for innovation because we already have all these financial applications out there that people are used to using. So not on the blockchain, but we could have blockchain alternatives, or we could have new apps that work kind of like these things, but give you better features powered by the blockchain. So some of the apps you might think of could be like Venmo, right? People use Venmo all the time to send money back and forth to their friends. Well, you could use a blockchain wallet for something like that. You might use a stock portfolio website where you have like an index fund or something like that, or you even have like a trading dashboard where you actually execute trades, right? We have cryptocurrency exchanges for all that, right? So we already have blockchain analogies to these types of things, and we can continue on building more apps with that, right? Powered by the blockchain, right? So we can create these apps with code that runs on the blockchain. And that's what I'm going to show you today. I'm going to show you today with Ethereum. We're going to create smart contracts, okay? And smart contracts are these digital agreements that live on the blockchain that can't change. And they're very powerful. I'm going to explain all that kind of high level in a minute. You don't have to know anything about smart contracts. You don't know anything about code in order to follow along. I'm going to explain everything in detail, okay? So, but what's going to allow you to do is create the building block of a blockchain application or a Dapp. That's going to be very powerful. It's going to be able to work with money in a what's called a trustless way. And I'm going to demonstrate that here right now. All right, so I've got this pulled up on my screen here. Essentially what this app is going to do is be a really simple app. What's going to allow you to do is take like cryptocurrency payment and send it, right? And instead of sending it to one person, we're going to create an app that's going to split it up and send it to other people, right? Essentially, like you can send it to one point, one time, and the app is going to handle the payment split between, two different people. And this could be theoretically 3 or 4 or 5 people, right? I'm actually going to just remove that. But essentially, it's just going to split the payment twice. You can think about this use case a bunch of ways. Like what if you wanted to create a tip on a bill or something like that? But that's kind of a trivial use case. I want to think about a more robust use case. Like what if you ran a business, right? And you agreed that every single payment that came through a business was split evenly between 2 partners or between teams or different vendors or something like that, right? This would be a very powerful way to create a payment gateway. Like say you ran an e-commerce website, for example. Anytime someone checked out through your checkout system, the payments would get split in a predictable way, right? Or let's say you had some sort of app that charged fees. This would be a way to like take fees off the top anytime someone sent money through a payment processor or something like that, okay? So that's what I'm going to show you to create is a payment splitter with a smart contract, okay? So why is this so important? Why would you use this on the blockchain rather than just some other method? Well, that's where the smart contract comes into play. It's a digital agreement, like I said. It lives on the blockchain, and we know it's not going to change. It's trustless. That's one of the reasons you use a blockchain in the first place is, to create something that no one has to know, like no one has to trust whether this is going to happen or not. So let me give you an example. Let's say we run a business and I say, you create the product and I'll sell it, right? Anytime sales come in, we'll split it 50-50. Well, how do you know that's actually going to happen? If I take the money from you, you have to trust me in order to say, oh, I'll give you my 50%. But if all the payments happen on the blockchain, you don't have to worry about that, right? Anytime someone pays for the item in the business, me as the marketing partner or the salesperson or whatever you want to call it would get my cut, and you as the business person would get your cut, right? You can think about this anyway. As a business or with friends, like say, you can do this in the opposite way. Like say you and your friends wanted to go out to dinner and you all got money and had to split the bill. You can do this in the opposite direction where you all paid into this, collectively and pool all that money and, a single payment went out to the restaurant or something like that. So all kinds of applications, that you could do that with. And then maybe the restaurant would find a way to integrate that smart contract, or they could pool, crowdfund bills or something like that, okay? All right, so how does this work? Talk about this smart contract being a trustless thing, and that's really important in that use case of business. So if you run a business and we're agreeing to split payments, it's a contract. It's a contract that says, if the money comes in, I'm going to give you half, and you don't want to trust each other. So that's what the blockchain is for. Basically, we're at code that says we don't trust each other, and it puts it on the blockchain. So why does it matter that it's on the blockchain, not some other traditional app? Well, if it's on the blockchain, it basically lives on a bunch of different computers. That's what a blockchain is. So, a blockchain is a peer-to-peer network of nodes that all talk to one another. Sorry, this is a really bad diagram, but you get the idea. All these different computers talk to one another, and each of these computers are going to get a copy of the code, right? So, whatever code we deploy, all these computers get a copy of it, and they have to achieve consensus that says, yes, all this code's the same. So that's a roundabout way of saying the blockchain is a redundant computer. It's a global computer. When we put the code on it, we know it's not going to change. That's different from another app where the developers could just say, oh, well, let's change, the fee on this to 20% or whatever, and then you don't know about it. Or even worse, I have access to the back end of the app as a business owner, and I say, okay, let's just change the fee to like 10% or whatever, right? And then the payment gets split up. So with a smart contract, you don't have to worry about that. If the fee is set ahead of time, it's going to stay the same. The payment's going to get split. And every time that happens, it's going to happen in a predictable, deterministic, right? It works the same way every time, and trustless. I don't have to trust you. You don't have to trust me way. All right. So let's go ahead and get some code for this. I'm going to get started coding. So I'm going to pull up remix.ethereum.org. That's how you can get started programming this app or this smart contract with me without having to install anything on your computer, right? You can do it all in your browser. So head on over to remix.ethereum.org. This is the new version of Remix. So if you used it before, you might see some changes, and this is an example. So I'm going to do this with Ethereum, right? That's what Remix allows us to do, is create smart contracts for the Ethereum blockchain. And I'm going to click Solidity. Okay, so that's the programming language that we write Ethereum smart contracts in. So click Solidity. And I'm going to say, let's keep this compiler version. And I'm going to create a new file. So if you go over here to the side, open up the File Explorer, I'm going to create a new file here. Click the plus icon. We'll just call this untitled.sol. All right. So inside of here, I'm going to actually write the smart contract code, right? We're going to write this in a programming language called Solidity. Looks a lot like JavaScript. You don't have to know Solidity in order to follow along with me. This is going to be very high level, very simple. I'm going to teach you as you go, okay? So what you do first in a smart contract file for Solidity is you declare the version of the programming language. We do that like this. Say pragma, Solidity, and we give it a version. So the compiler specified 0.5.1. All right. And next what we're going to do is actually create the smart contract. We do that like this. We say contract. That's the keyword. And we'll just call this smart contract payment. Okay, so payment. All right. So inside of here, we want to do a couple things. Right? I'm going to go back to my whiteboard. So we're going to keep track of who gets the payments, and then we're actually going to split the payments and create a function that does this. So anytime, someone sends, the payment to the smart contract, it's going to send it to, two different people. So we're going to keep track of user 1. And we're going to keep track of user 2, okay? Sorry, it's really bad handwriting, but I think you get the idea, okay? And so the payment that's going to come in is actually cryptocurrency. So it's Ethereum. That's the cryptocurrency that's native to the Ethereum blockchain, or we call it Ether, okay? And we can represent Ether a few ways, which I'll show you. But essentially what's going to happen is we're going to create a function that accepts Ether, Ethereum cryptocurrency, and whenever it gets it, it's going to split it two ways, send it to user 1 and the user 2, and this will be a 50% split, okay? So go back over here, and I'll show you how to do that. First, we can keep track of user 1 and user 2. All right, we'll do that like this. We're going to use a variable inside the smart contract that's called a state variable. So what does that mean? Well, a state variable essentially is a variable that gets stored on the blockchain inside this smart contract. So you could have a couple different types of variables, like local variables inside functions or variables in the smart contract. The state variable basically just says this value belongs to the entire smart contract and it gets stored on the blockchain, okay? So we can create a state variable just inside the smart contract like this. We can say address, and we'll call this user 1. So that'd be a very simple way just to declare the state variable. But what we can do is even further, we need to tell Solidity what this address actually is, okay? So I'm going to go here on this tab, and I'm going to click this run and deploy. And I'm kind of jumping ahead here, but I'll just show you. I'm going to click the second account in this list. All right, click it, click copy. I'll go back to my file, and I'm going to paste it here. All right. And this is going to be the Ethereum address for the user that's going to get split. So we're going to get two addresses. Going back to our demonstration here. This is an Ethereum address, and this is an Ethereum address. That's how we basically represent people on the blockchain. We have accounts. And each account has an address. It's like your username on the blockchain. Like it's your public key, essentially. Kind of like your public key. So that's user 1. And we can tell Solidity that this person can receive money with payable. It's a modifier for the variable. It says this person can receive cryptocurrency funds. And we're also going to create a variable for user 2, just like this. So we can say address payable user 2. All right, we're going to go back to this tab here, and we're going to copy it. So let's do this. User 2, copy it, come back, and paste it in here. All right. So now we've stored each user. So whenever we send the payment, 50% is going to go to this address and 50% is going to go to this address. These are just like the usernames on the blockchain. These are the accounts, the Ethereum wallets. So I'm going to go here and I'm going to compile this. So compile, and it's probably going to give me an error. All right, so it does. It says it's not in checksum format. That's just a fancy way for saying that it doesn't have the correct capitalization in certain places. So I'm just going to copy the correct suggestion here. If you get this kind of error, you can do the same thing. Just copy that and put it back in here. It gives you an error message and then tells you what the right thing is. So I'm going to compile it. And compilation is just a step that we have to do in the smart contract to take the source code, the code we write as a developer, and compile it down into code that the blockchain can understand, right? So we'll go back to the source code, and that gets us past the first step, where we can just create the two accounts that we're going to split it with. All right. So now let's actually create this function. This is going to be a function that receives payment in the smart contract and then does the splitting. Okay. So we can create the function like this. All right. We'll just use the function keyword, function. All right. Followed by open and close parentheses. And inside of here, we're going to do the splitting. Okay. So we'll do this pretty easily. We'll basically just say user 1. And we're going to say transfer. And then we're going to pass in the payment amount divided by 2. That's going to be a 50% split. Okay, so there's a couple things we need to do here. We need to get access to the actual payment amount, like where's the money coming from, and then we need to divide it by 2 so that it gets sent over to the user. Okay, so you can access the money that's sent to this function with this global keyword in Solidity called MSG, or message, MSG, and say .value. All right, that's going to be the actual money that comes in whenever this function is called. Okay, And we can say just divided by 2. That'd be 50% of the payment. All right. And then you can do the same thing for user number 2. So you say user 2, transfer, msg.value, divided by 2. And that's actually going to handle the payment splitting, okay? And there's a few more things we need to do in order to make this function work, all right? So right now, there's a problem with this function. It's only like, you can only use it inside the smart contract. Basically, I can only call this function from another function, all right? So we want to be able to call this function outside the smart contract. And we do that with something called external. This is just a modifier. This basically tells Solidity, the programming language, that this function is visible outside of the function, outside the smart contract. And then we also need to tell Solidity that this function is payable, like this. So what does that mean? That means that anytime you call this function, that you can send money with it. You can send cryptocurrency, and it's going to have this msg.value populated anytime the function is called. Okay. All right. So now what we want to do is actually try this out. Okay. So we've compiled the smart contract. We can do that again. We can go to this page here, click compile. All right. So no warnings, no errors or anything like that. And now what we can do is actually deploy it to a blockchain. So we're going to take the code, put it on a blockchain, and use it. We're going to actually take some cryptocurrency, send it to this app, and it's going to split the payments to 2 different people. Okay. So there's a couple different options here. I'm going to click the JavaScript VM, that just stands for virtual machine. Basically what this does is gives you a fake blockchain in your browser, which is really nice. It means you don't have to download anything on your computer, you don't have to install anything, you just have a blockchain ready to go. And I'm going to go ahead and select the first account in the list, and I'm going to click deploy. All right, there we go, it worked. So now it's on the blockchain, and you'll see that some money came out of this account. That's because anytime you use the blockchain, you have to, anytime you put new smart contracts on the blockchain, you pay a gas fee, right? Some small amount of Ethereum cryptocurrency in order to create a transaction. That's what this does, okay? So now let's actually try it out. I'm going to stay on this account. I'm going to try to pay the smart contract. So you can see this new window right here that popped up. This essentially is the smart contract, and here's the function name. It's called fallback, okay? So I'll explain more why it's called that in a minute, but let's just go ahead and give it a try. So I'm going to call the function, and it's important to send money when you do it. So you can do that up here with value. I'm going to click 1, and I'm going to say Ether. Okay, and click fallback. All right, boom, there we go. So we can see our account balance went down by 1. And if you go here, you can see that 0.5 Ether was added to the other accounts in the list. All right, so it worked. Awesome. Our payment splitter works. We can see that the payment was clearly split 2 ways in a trustless way to each account. All right, so now let's explain it a little more, how it works. So this fallback function, it works a very specific way. So essentially, this function can get called anytime that I send Ethereum cryptocurrency to this smart contract. So this function could have a name like, I could say pay, right? That could be a named function, but I didn't do that. I let the name off of the function. And whenever you do that, it allows you to just take the smart contract address and like put it in a wallet like MetaMask and just send money to it, and this payment would automatically be split, right? So here's an example of a MetaMask wallet. This is an Ethereum wallet. So like normally I could take your account address and put it inside of here and just click send, and it would send Ether, the cryptocurrency straight to you, right? Or what I could do in this case is just take the smart contract address, which is, this right here, just take it, and then put it inside, could just say send, and I could paste it in right here. And then just, whenever the send button came up, just click send, and it would send the payment to that thinking it's a person or something like that. And it would automatically split the payment 2 ways into, each account. And that's what's amazing. Like you could say ahead of time, hey, send Ether to this or send cryptocurrency to this, and it's automatically get distributed to a bunch of different people. And that's the power of the blockchain. You can integrate this into a checkout system. You can integrate it into any business or any contract where you wanted to have a predetermined agreement that anytime money was sent, that it gets distributed to this person, that person, that person, in a predictable way. Okay. And you don't have to trust it. You don't trust me. You just have to trust that the contract's going to work. All right. So, yeah, that is the power of the blockchain. And that's where I see innovations like this happening more and more in financial transactions. Now, this is a very simple smart contract, but they get you started into understanding, how this works for other blockchain smart contracts, other blockchain use cases involving payments, finance, money, anything that we use value for right now. I think we're going to see some major adoption with blockchain very soon, right? We're already seeing it with cryptocurrency. People are buying cryptocurrencies. They're paying with them. We have apps, really cool decentralized apps that are, working with cryptocurrency, cool dApps, right? So hope y'all like this video. Be sure to subscribe to the channel if you haven't already. Click the like button down below. And if you want to learn more about how to build blockchain technology, you can join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.